Okay, good morning, everybody. So today we're going to go ahead and go through 11 through 19. This is going to be the multiple choice of the Canary section. So here we go. Okay, so hopefully you guys can see that okay. That's a little bit better. Okay, so R be the region between the graph y is equal to e to the negative 2x and the x-axis, where x is greater than or equal to 3. The area of R is what? Well, it might be nice to know just exactly what this is going to look like. So this is an exponential function, but it's exponential decay because it has a negative exponent. So the graph of this one is going to come down like this, and we're going to go from x is equal to 3 outward. So we want to find out what the area is. So all we need to do is integrate from 3 to infinity of the function e to the negative 2x dx. This is an improper integral, so we need to rewrite it. It's multiple choice. You don't really have to, but I'm just doing it to refresh your memories of how to do it. So you write the limit as a goes to infinity, and we're going to go from 3 to a of e to the negative 2x dx. Okay, so integrating that, it's an e to the x function. So you get e to the negative 2x, but divided by 2, because you have to divide through by the derivative of negative 2x. So this will be the limit as a goes to infinity, and we're going from 3 to infinity. Okay, sorry, to a. Can't plug it in yet. Okay, so this is equal to e to the negative 2a all over 2 minus e to the negative 6 power all over 2. And I'm missing the limit here. Okay, now as a goes to infinity, this is going to get bigger and bigger and bigger, but it's a negative, so it's actually in the bottom. So this whole entire thing is going to end up going to 0. So the answer is just, and I goofed up here, I'm sorry. The derivative of negative 2x is negative 2. So this should be a negative, that should be a negative, that's a positive. Sorry about that. So when you do this, you get 1 over 2 e to the 6th power. So the answer is A. Okay, number 12. Okay, so which of the following converge for all real numbers? This should be pretty easy for you. I just have to remember which one dominates, okay? If it's going to converge, then the limit of this expression has to go, or the argument has to go to 0. So if you take a look here, you have an exponential function. Now, it does say for all real numbers x, okay? So x could be 1,000 if you wanted to. And if it was 1,000, this is going to go to infinity a lot quicker. That is anything bigger than 1 it is. So this is not going to converge. Same argument down here, even though this is n squared, it's still not going to converge. The square root of n, still not going to converge. Now you got to remember which is the most powerful. So the couple that we really work with is n factorial and n to the power of n. N to the n is more powerful, goes to infinity faster than what n factorial does, but there is no n to the n here, so the n factorial is going to dominate. So you should know that this is going to be the one that converges. So I know for sure that that's going to go to 0, which has to happen in order for it to converge. So let's actually take a look what happens in the next one. We know n factorial is on the top, n factorial goes to infinity, so this thing is going to diverge. My only answer here would be D. And if we actually went through and did something like the ratio test, we'd see that it converged for all real numbers x. Okay, next one. I always crack up how easy it is, but how difficult everybody makes it. And I think honestly, it's like one of those things that you make it more difficult than what it is. So when you first see this, there's a lot of things that are going around in your head. Maybe trig sub, ooh, because you have x squared plus 1. It kind of makes you think of that. U sub, because the derivative of x squared gives you the x. But remember, that's not x. It's 1 over x. So U sub's not going to work here. But I did go back and I talked about this a long time ago. When the power of the top of the numerator is more than the power of the bottom, or the degree of the numerator is more than the degree of the denominator, you have to divide it out. Well, this is pretty simple. We just use the distributive property of division. So this is actually equal to the integral from 1 to e of x plus 1 over x. Okay, makes it a lot much more simple. So the integral of x is x squared all over 2 plus the integral of 1 over x is ln of the absolute value of x, and we're going from 1 to e. Okay, so plug it in. So you get e squared all over 2 plus ln of e minus 1/2 minus ln of 1. So this is equal to, well, e squared over 2 is just e squared over 2. Ln of e, you should know, is 1, so plus 1, minus a half. And then you also should know ln of 1 is equal to 0. So we just have this, which is e squared over 2 plus 1/2. So the answer there is B. Okay, number 14. Okay, the polynomial function f has selected values of its second derivative f double prime given in the table above. Which of the following statements must be true? So this is a pretty classic type of problem. You see this a lot, and the first three in particular, they absolutely bait you into thinking that something's right. Okay, so f is increasing on the interval from 0 to 2. Almost always this is going to be false in this type of a question. And the reason why is because, and I know this is a second derivative, so what I'm going to say is technically doesn't necessarily apply to this problem, but just imagine that this was the first derivative and you saw that this is positive, which means it's increasing, 0, which means it's not doing anything. Once again, if this was the first derivative, negative, so it's decreasing, and then 4, which means it's increasing. It'd be really tempting to say, okay, I know where it's increasing and decreasing, but the thing is you have no idea what is going on between 0 and 1. There's no information there, and there are an infinite amount of different points. There's a uncountable number of points between 0 and 1. You don't have any idea what's going on there. So I have no idea that that's increasing for all those values. I have no idea that that's decreasing for all those values. Local maximum at 1, they're actually trying to bait you into thinking that this is the first derivative. So the first derivative is equal to 0, it goes from positive to negative, so it'd be a local maximum. But once again, this is the second derivative, not the first derivative, so we don't know that that's true. It has a point of inflection at 1. This looks to be true. At 1, the derivative 0, it goes from positive to negative, so it appears that that is true. Once again, though, you have no idea what is going on between 1 and 2. Maybe it's the case right after 0, everything is positive. It goes down, it touches 0, and it goes back, and it's positive for a while, and then it goes to -7. So we have no idea what happens there. So I can't actually make that statement. Now, this one's kind of tricky because it says the graph of f changes concavity in the interval from 0 to 2. Okay, so from 0 to 2 goes from positive to negative, so it looks to be true. But here's the thing, 2 doesn't count. That's not in that interval. So I actually can't count this -7. All I know then, it goes from 5, a positive, to 0. That's all that I know. Okay, so why is it that this is the one that is true? The reason why it's true is because it can't jump from 0 to 7 instantaneously. Okay, it has to be able to go there eventually. So right before 2, this would be like some sort of negative value there as well. Okay. Number 15. If f of x is equal to ln of x squared, then f double prime of the square root of e is. So we have to take the derivative, the first derivative. So first derivative is you bring down the 2, you decrease it by a power of 1, so 1, and then you multiply it by the derivative of ln of x by the chain rule, which is 1 over x. Okay. Then we have to use the quotient rule to take the second derivative. So I go low, d high, so the derivative of 2 ln of x, well, 2 is just a constant, so it's 2 over 1, or 2 times 1 over x, so 2 over x, minus high, d low, the derivative of x is just 1, all over low low. Okay, cleaning this up, the x's will cancel, so I have 2 minus ln of x squared. While I'm writing down the x squared in the bottom, try and think of where did this x squared come from? Okay, so you have x squared there on the bottom. Now, where did this x squared came from? Property of logarithms. There's a 2 in front of ln, so you can go ahead and bring it up, so you write ln of x squared. Okay, so then we go ahead and plug in a value. So f of the square root, f double prime of the square root of e is equal to 2 minus ln of the square root of e squared, all over the square root of e squared. So this is going to be 2 minus, so the square root of e squared is e, ln of e is 1, so it's just minus 1, all over e, so 1 over e, so the answer here is A. Okay, number 16. A few more left. Okay. What are all the values of x which the series converge? This is a tricky one. So I'm going to go ahead and use the nth root test. And so the root test is we have the limit as n goes to infinity of the nth root of 2 all over x squared plus 1 to the nth power, which is equal then to just 2 all over x squared plus 1. Okay? Now, why is this so? The nth root of n, those go away, and you're just left with this. Well, what about the limit? This is limit as n goes infinity, which is nothing. Okay, there's no n's there anymore. Okay, so in order for this to converge, I know that this has to be less than 1. Okay, and so then I multiply across. So I have 2 is less than x squared plus 1. So I have 1 is less than x squared. So I know x has to be between -1 and +1. Okay. I do have to go through and check the endpoints, -1 and +1. So where do I go? I go back to the original. So going back to the original, I'll plug in -1. So if I square -1, I get 1. 1 plus 1 is 2. 2 over 2 gives me 1. 1 to the power of n, that is going to diverge. Okay, it's just a bunch of ones added together. Same thing can be said for 1 here. So the answer would have to be A. Now, there's an easier way to do this one. Okay, if you do notice, what do you notice about this? You have something raised to the power of n. Well, that's just geometric. And what is the rule for geometric? If the common ratio is less than 1, it converges. So I could have gone right from the very beginning and just said that thing has to be less than -1. Well, look, that's what that is. Okay, so we have two different ways, well, at least two ways to do this. Okay, one by actually going through and do the root test, but this way is a different way, and it's just looking at it as in terms of geometric. Okay, number 17. Let h be differentiable function, and let f be the function defined on f of x equal to h of x squared minus 3, which is defined is equal to f of 2, or f prime of 2. So you got to take the derivative. So f prime of x is equal to, so take the derivative of the function, so h prime of x squared minus 3. But by the chain rule, you have to multiply by the derivative of what's inside. So that's going to give me 2x. So then evaluating f prime of 2, so you can plug 2 in there, you get 4 h prime of 4 minus 3, which gives you 1. So 4 h prime of 1. So the answer there is B. Pretty simple. Okay, last two, 18 and 19. Okay, 18. In the xy plane, the line x plus y is equal to k, where k is a constant, is tangent to the graph. Okay, so as soon as you see that, you should be thinking to yourself, I have to take the derivative of something. Okay, don't know what it is, but that's like a giveaway. Okay, so tangent to the graph of y is equal to x squared plus 3x plus 1. What is the value of k? Okay, so we have some sort of a curve here. This is a parabola. And I know that this line is going to be tangent to it. So whatever it looks like, and I don't know exactly what it looks like, but maybe it looks something like that. Okay. We need to figure out what the x and the y value are there, because if I figure out the x and the y value are there, it will tell me k, which is my answer. Okay, so tangent to the graph. I need a line that's tangent to the graph. Well, there's the line. I'm actually going to rewrite it a little bit, though. I'm going to put it in everybody's favorite slope-intercept form. So I have negative x plus k. Now, in doing so, I know what the slope of this tangent line is. It's -1. So what do you normally do? You take the derivative, you plug in the value, and you get what the slope is of that tangent line. Well, I know what the slope is of that tangent line. It's -1. So all I'm going to do here is take the derivative here and set it equal to -1. So y prime is equal to 2x plus 3. I have -1 is equal to 2x plus 3. I have -4 is equal to 2x. I have x is equal to -2. It's really easy to jump off the cliff here and say, oh, x equal to -2. It's right here. That's not the case. What am I looking for? I'm looking for k. So in order to find k, we talked a second ago, is we have to figure out what the xy value is. Because if I know what the x, y value is, I just plug it into this equation and it tells me what k is. So take -2 and plug it in here. So y of -2 is equal to -2 squared plus 3 times -2 plus 1. Y of -2 is equal to 4 minus 6 plus 1. So y of -2 turns out to be equal to, so -2 plus 1 gives you -1. Okay, so all I need to do then is take the x plus the y, so -2 plus -1 gives you -3, which is my k value right there. Okay, last one for today. Okay, 19. Oh, right away when you see this, you know what to do. You absolutely know what to do. Partial fractions, right? Why do I know that? Because you have these two binomials that are being multiplied times each other. It'd be really easy to split it apart. Okay, so I'm going to go a all over 2x minus 3 plus b all over x plus 2, and that's going to be equal to 7x all over 2x minus 3 times x plus 2. Okay, so go ahead and combining common denominators here. Remember what I do? I always just ignore the denominators, because if you have two fractions that are equal to each other, the denominators are equal to each other, then the numerators have to be equal to each other as well. So I have a times x plus 2 plus b times 2x minus 3 is equal to 7x. Another way of viewing that too is if I multiply through by 2x minus 3 times x plus 2 on both sides of the equation, I would end up with this. Okay. Now I have to come up with a clever substitution that will make one of these terms go away. So if you notice here, if I let x be equal to -2, that's going to go away. And I'm left with b, so -2. So I have -4 minus 3 gives you -7. So I have -7b is equal to 7 times -2 gives you -14. So b turns out to be equal to 2. Okay, so furthermore, I have to go over here and pick something clever to make that go away. It's a little bit more different or difficult, but I'm going to let x be equal to 3 halves. Now, how did I know that? There's a couple of ways, just by inspection, just looking at it and knowing that's what it is. Right? When you plug in 3, the 2's are going to cancel. You're left with the 3 to make it go away. If you didn't see that, if you just can't see that in your head, just go to the side. Go over here and say, okay, I need 2x minus 3 to be equal to 0. So 2x is equal to 3, x is equal to 3 halves, right? Okay, so letting x equal to 3 halves, so I have a times 3 halves plus 2, that's going to go away, is equal to 7 times 3 halves. 1.5 plus 2 is 3.5. 3.5 written as a fraction is 7 halves. So 7 halves a is equal to 21 halves. Hopefully from here, you can see that a has to be equal to 3. Right? You can multiply both sides by 2 7s and you end up getting 3 here. But if you just compare, inspect it, you know that a has to be equal to 3. Okay? So what we have then, I know what b is, I know what a is, and I can go back and rewrite this integral. So the integral can be rewritten as a, which is 3, over 2x minus 3, plus b, which is 2, all over x plus 2 dx is equal to, so I have 3, and hopefully you recognize that these are both ln functions when you integrate those. So automatically I can go and cross off d and e. I know those will not be the answer because I have to have an ln in there. So I have 3 times ln of the absolute value of 2x minus 3. So you can see those 3 have that in there. But by the reverse chain rule we always talk about, you need to divide through by the derivative of 2x minus 3, which is a half, and boom, we have our answer. We don't even need to go any further. Okay, if we did go any further, we'd get the rest of it, but this is the only one that has 3 halves to it, so the answer there is going to be A. Okay, and that's it. Hope you guys learned some things today, and we'll see you tomorrow.